11.1 Designing a study. So in this first part of the lesson, we're going to talk about different ways to design a study. Now your first question might be, why do we want to design a study? Well, a lot of times it's to answer questions about a population or a parameter. Sometimes due to time and money constraints, it's not cost effective to do a study of everybody in the population, so instead we take what's called a sample statistic. So for example, the census. Right, that's where we try to count every single person that lives in America. Now, by law, we have to do a hand. It takes forever, and it's not cost effective. So a lot of people would suggest we do a statistical thing. We take a random sample, and then use math to figure out what the total population is. So that's what a statistic is. Now, a lot of times, we're going to talk about how to design a study. So what are the first steps to designing a study? Well, first, you want to talk about you want to identify what you want to study. So in this example I had here, it's number of people in America. Then choose a sample to collect data. But again, by law, we have to choose everybody, but as the general, choose a sample. Organize the data. Once you get your data, organize it, calculate statistics, and then make conclusions on it. That's how you design a study. Now, there's some issues sometimes. We'd like our stuff to be called unbiased. A biased sample is when there's error in there, when there might be so much representation. For example, let's say Almont got a free $1,000. Now let's say we try to figure out what to do with that money. And let's say we only pulled all the senior homerooms. They might be like, hey, let's spend that money on an awesome prom. That would be a biased sample. Why? Well, only seniors and juniors will go to prom. How about the freshmen and sophomores? They might want to spend money on something else. So to make it unbiased, we do what's called a random sample. Instead of just senior homerooms, we pick a random sample of all the homerooms. That way we have a good mix of seniors, freshmen, sophomores, and we could get a good idea of what everybody likes to spend the money on. So that's a random sample. Now let's talk about different ways you could do a study. There's three main ones. You could do a survey, which is just as it sounds. You give a little form, you fill out a survey, a little questionnaire. That's a survey. So for example, we're trying to figure out what's the best food to have in the cafeteria. The best way to do it is to just give a survey to the students. That's what it says here. The next way is an experiment. Now, an experiment is a little tricky. You generally need a control group, which nothing happens to. They'll let you know like what's the normal, and their experimental group, which you actually do something to. So for example, I have two honors algebra 2 trig classes. Let's say A and B. If I was going to try to flip a classroom and see how good that works, what if I just flipped one of them and not the others, and I did the other one normal? This would be my control group. I didn't do anything. I just taught it normal, taught it in front of the class. My experimental group would be the flip class. And then I could see what the difference was. So that's an experiment. An observational study is this kind of like you see in TV shows and movies where there's like a plated glass, a one-way mirror, and then there's like people discussing like a product over here, like talking about it, and there's people on the other side. This is my amazing art, by the way. Talk on their way discussing what they see. That's an observational study. You give people something to work on, and you observe it from afar. The book example: researchers at an electronics company observe a group of teenagers using different laptops to know their reactions. So that's the kind of idea. So you do have a survey. We just give them a survey to fill out. The experiment, we have two groups. You kind of have the normal group, and you have the group where you actually do the stuff to. And then you have the observational study where you kind of step back and just like observe. So now that we know what type of groups are, let's classify some types of studies. So this first one. Scientists study the behavior of one group of dogs given a new heartworm treatment and another group of dogs given a false treatment. So notice how there's two groups. There's one that has the normal, they're given a placebo, which means that it's like a sugar pill, there's nothing there. And another group is given the heartworm treatment. Hopefully my dog's in the heartworm treatment group. So this is called an experiment. This is identify the sample and suggest population from which they've been selected. So a sample would be a sample of dogs. Dogs with heartworm would be the sample, actually. If you have dogs without heartworm, what good is the experiment? So dogs with heartworm. The next one. The yearbook committee conducts a study to determine whether students would prefer to have a print yearbook or both print and digital yearbook. So this is a good way to do that. If we did an experiment, that'd be kind of weird. You're gonna give like half the student body a print yearbook and half the student body both of them. I'm not sure if that have us be happy. Observational study, you just kind of give them both and look from afar. That could kind of work, but the best one's probably just a survey, right? Just ask the kids, hey, which one would you like, both, or would you like this to print yearbook? So survey. Sample, probably like a select group of the subgroup of high school students. That says high school. We'll move on. A group of high school students randomly selected and asked to complete the form below. Survey. Look at that. Can't get more survey than a survey. That's the surveyest thing I've ever seen. Next, an advertising company wants to test a new logo design. They randomly select 20 participants and watch and discuss their logo. That is an observational study if I've ever seen one. Right? They're giving them the new logo. Then they're like, hey, we're gonna go talk about the logo right here. That's people talking about the logo. I'm like, look at that logo. And then there's people on the other side like, ooh, look at them talking about that logo. It's an observational study. But I got fun. Example 2. So same idea. Now they're gonna have questions they want us to come up with. Which one should we do? Right. So first one. A research company wants to study smokers and non-smokers to decide whether 10 years of smoking affects lung capacity. So again, now they want us to decide which one should we use. Should we do a survey? You just want to survey the smokers, like, hey, how good are your lungs now? You want to do an experiment? That seems kind of harsh. You guys that don't smoke, start smoking for 10 years. And you guys that don't smoke, don't smoke for 10 years. So not going to be either of those. It's going to be an observational study. You're going to find 10 people that do smoke, 10 people that don't smoke, and see how it carries on through the 10 years. So remember, an experiment, you have to have a control group. You can have one here, but experiment's more like active, like you're gonna make another group do things. Next, a national pet chain wants to know whether a customer would pay a small annual fee to participate in a rewards program. They randomly select 200 customers and send them questionnaires. Well, if they're gonna do that, that's a survey. The realisticity group wants to determine whether high school students that participated in a recent national reading program had higher standardized test scores than high schools that did not participate. Some people might say survey here, like just question them, but I think you'd be afraid that they're not going to get the right answer. Experiment would be another, like, oh yeah, you're good at reading, I don't care, we're going to put you in this, you're bad at reading, we're going to put you in the reading program. Oh, you're good at reading, we're not going to put you in it. So that's not good. This is an observational study. So you're going to observe, in a distance, how do people do that don't take the reading program and that do take the reading program. Research department of a retail company plans to conduct a study to determine whether a dye used on a new t-shirt will begin fading after 50 washes. You know what this is? An experiment. You do 50 washes with the new dye, and you do 50 washes of a different shirt without the dye, and see how they go. Classic experiment. Let's talk a little bit more about the design study. So one thing we're going to focus on right now is watch out for biased questions. So how do you get biased questions? Well, they could be confusing or wordy, trying to mess you up. They can encourage a certain response. That's really the key. If they're trying to get you to respond a certain way, that's a biased question right there. So if it's trying to encourage a certain response, tries to cause a strong reaction, get you off your game, or addresses more than one issue. So we're trying to identify something's biased or not. So this first question: how many glasses of water do you drink a day? So first, get off your high horse. That's unbiased. They're just asking, hey, how much glass of water do you drink a day? Nothing wrong with that. Unbiased. Look at the next one. Do you prefer watching exciting action movies or boring documentaries? You see how they're trying to lead us to pick action movies, and by trying to shun away documentaries. I like documentaries. This is bias. They're trying to get you to lean to pick action movies, right? They're trying to encourage a certain response to picking action movies. So a couple more. Which student canceled candidate's platform do you support? Again, notice they're not trying to lead you a certain way. They're just asking a special question. That's unbiased. How long have you lived your current address? Again, they're not trying to lead you a certain way. That's another unbiased question. Stephen Colbert would have a classic example of a biased question. He would ask, George H.W. Bush, George W. Bush, great president or greatest president? That's kind of a joke. And that's a bias question, right? You only have two options, both of them lead you a certain way. So that's an example of a bias question. So let's talk about 11.2 now. 11.2 is all about after you got all your information from your survey and all your data, what do we do with that data? Now, we're going to collect the data, and it generally goes one of three ways. It could be negatively skewed, symmetric, or positively skewed, once we label our data. Now, the key thing here is this, understanding what each one means, and it's a little funky. Symmetric's the easiest one. Symmetric means it goes right down the middle. Key thing here with the symmetric graph, look at that graph. Right, the key thing is that the mean, the average, equals the median. Remember, median is the middle number. So they're both right here. Right down the middle. That's the symmetric data. Equally on both sides. Now the next couple ones where it gets a little tricky. Look at this one right here. A lot of people want to say this is positively skewed. Like, oh, look, it's all going to the top. It's actually the opposite. It's negatively skewed. Let me explain that. If you look at this, right, people do really well on this test. If this was test scores, that'd be awesome. They did great. The middle, the median, the middle person in the class got a high score. But look at this, the average is lower. Why? Because a couple of losers brought the score down, right? It's lower than what it should be. Average should be, we did really good. Average should be great. A couple of losers brought the score down, so average is lower than what it should be. Just joking, not losers. Just need more studying. Right, the key here is look at the tail. The tail tells you what it is. If the tail's on the left, it's negatively skewed. Also, if the mean is less than the median, right, that means the average is lower than it should be. They should be equal. That's what we want. We want the mean and median to match up. If the average is less than the median, that means that there's some couple people that lower the scores. So we call that negatively skewed. Shortcut, just look at the tail. Likewise, look at this one. Look, if that was a test score, you're like, ooh, everybody failed that test. What happened? Why is this called positively skewed? Well, a couple Fregoso wannabes aced the test and brought up the average, ruling the curve. So we call this positively skewed because it's more positive than it should be. This should be a bad test, but a couple people brought the score up, so it's higher than it should be. Again, notice the middle's right here. In this case, the mean is bigger than the median. I was thinking like a number line. Like here's the median right in the middle. If the mean's on this side, it's a bad number line. Here's a slightly better one. Here's the median right in the middle. If the mean's on this side, then it's positively skewed, right? The average is higher than it should be. If the mean's on this side, below the median, then it's negatively skewed. So that's the idea. The trick is, again, let's look for the tail. Tail tells you where the answer is. So positive or negative skewed. Again, positive skewed, average higher than it should be. Negative skewed, average lower than it should be. This is how you see on the Boston-Worcester graph. Same idea. Notice right here. That tail is really long, so it's positive skewed. This tail is really long on this side, so negatively skewed. Right, again, those people right there, there's a couple people that scored really bad and brought the score down. On this side, everybody did bad, but a couple people brought the score up. And then symmetric's right in the middle. Okay, so let's talk about how to draw a histogram on our calculator. So we're going to put this data into our calculator and make a histogram, which I'll talk about in a second. So get your calculator out. I'm going to type all these numbers in. Let me not cover up the numbers. I'll do that right now. Okay, so I just entered in all the data, hit enter. So there's 24 things we've entered in. Now it wants me to use a graphic calculator to create a histogram. So histogram is a box graph. Sorry, is this. Right, so normally that's a table graph. If I want a histogram, that's a bar graph. That's what it's called. Man, that's embarrassing. I couldn't think of it for a second. It's a bar graph. Okay, sorry. Histogram is where it's all connected. We'll talk about this more later, but when it's all connected, we call that a histogram. Well, how do we do this on our calculator? Well, after you have all your data, we're going to go to second stat plot. We're going to turn one of them on. And over here, well, let's turn it on. And over here, it lets you decide which type you want. Do you want a dotted line, scatter plot? Do you want to connect the scatter plot? Do you want a histogram, or do you want a boxing wizard plot? So we hit that. We have X1, L1. I do not have a frequency list, so let go of it, and then we're gonna hit graph. And I could kind of see something. You know why? Our window's off. Let's go to window, and let's go to stat to zoom 9. You just hit 9. I just want to show you it's there. And you can like this. So there's our histogram. And from there you can kind of tell it looks like it's positive. Sorry. Oof, that's embarrassing. It's negatively skewed, right? Look for the tail. If I drew it, if I kind of connected it, it'll be negatively skewed. Right? It look kind of like. It'll kind of go like this, you know, with the tail. So negatively skewed. So this will be a negatively skewed graph. Describe the center and spread of data using either the mean and standard deviation or the 5-number summary. So we really haven't talked about standard deviation, but the 5-number summary would be this. So stat, calculator, one variable stats. We did this earlier. Again, no frequency. Go to calculate. Now look at our mean is 20.5. Let's go down to our median. There's a standard deviation, but we haven't really talked about this yet. Our mean is 22.5. And again, it's kind of like a number line. This is the middle, the median. This is 22.5. Our mean is below it. It's at 20.5. So we're negatively skewed. It could be, there's a couple of low scores that brings it lower than it should be. So again, negatively skewed. Let's do this one. The total number of times 20 random people either ate at a restaurant or bought fast food in a month are shown below. And then we're gonna do a boxing wizard plot this time. So I'm gonna put the data in my calculator once again. Stat, edit. Now remember, if I want to clear this, do not hit delete up here. Hit clear. That clears it. You don't lose your thing. You're all good. Now you put data in. Again, it's all in there. So I'm gonna hit stat plot. Sorry, second stat plot. My plot's already on, so adjust it. Now I'm gonna go to the boxing wizard plots because that's what it wants. Now there's two here. This has an outlier, which we won't talk about in this class. I'll talk about next class. This does not. We'll use that one. Again, hit graph, and you can kind of see it. Again, my window's off, so I'm gonna hit zoom 9. I get a nice, zoom 9. I get a nice better window. And look at this. It's actually, in this case, it's a lot easier to tell. It is positively skewed. Look for the tail. Positively skewed. We can do the same thing with this 5-number summary. That's like we did last time. We go stat, calculator, one variable stats. Again, no frequency. Hit calculate. My mean is 9.1. My median is 7. So again, I'm above it this time, right? If I draw like a line, my median is the middle. This is 7. My mean's over here at 9.1. So there's some scores that really have that's bringing it up higher than it should be. So that's why it's positively skewed. Okay, let's do one more. Or we're going to compare distributions. Ooh, which one do I want to do? That looks like it has more. Okay, we're going to do this one. Because I'm lazy. So, compare data using the boxing wizard plot. So they want us to compare these points scored per game by a professional football team in 2008 and 2009 are shown. So they want to compare these two. We're going to put them both in our calculator. What we're going to do here is we're going to make one of them L1 and one of them L2. So we'll type them into our calculator right now. Okay, I put them both in there. So now what I got to do is I want to turn on two stat plots. One for the L1, one for the L2. So over here, I'm going to turn this one on. We also want to make another boxing whisker plot like that. Notice there's only one list now, L1. Again, no frequency, so leave that clear. I'm going to hit graph. You can see there's two graphs there. Let me fix my window again. Zoom 9. And did I put the same thing? Oh, you know what? That's my mistake. Classic mistake. I'm a rookie. What happened there is they're both L1. See how it's L1? I've graphed down 2 times. I got to graph this one. So I'm going to go down to L1. Let me put L2 there. So now when I graph it, frequency one's fine. I get something like that. Let me fix the window a little bit. Right, now they're different. And you can see, in 2008 it looks like it's symmetric. In 2009 it's positively skewed. So again, that means that they scored low, but there's a couple scores bringing it up. So this one is symmetric. Looks like a good year for them. This one is positively skewed, which means they did bad, but could be a couple scores about to average higher than it should be. Right, and you can compare. Look how much better that first season was. Like their lower quartile is their upper quartile here. Like that means that again, this is like their lower 25% was equal to their highest 75% or the lowest 75% here. So not a very good second season. And then we could compare that using just like I did before, but that's the general idea.